Hey ladies and gentlemen, what's up? It's Papa Bale. Welcome to the channel. Please like, subscribe, and hit the notification bell. Share if you like this content. So you spin one tube and you kind of get a rotation. Kind of get the concept of what happens. But if you spin them both, you get a better concept. And then all four of them spinning, it's going to be pretty. But this ring is supposed to go around this magnet. And it will. I'm just building two new stands with the holes in a little bit farther because, yeah, it's too small. The ring's too small and it's 7 inches. So I moved the holes in. See, because when I hook the motor up in it, in the ring, I'm going to make a triangle. I'm going to have coil and everything you need to run it in each section, which will go from this notch to that notch. And I'll even put like a board or something to illustrate that. And then that triangle will wrap around that rectangle. And it would be a 3-phase toroidal counter-rotating motor. I bet if we got that spinning fast enough, especially after we move the holes in a little bit, that magnet will make the aluminum spin. I think it's going to be great if it works out exactly the way I want it to. But right now I'm just making brackets here that fit this ring. And then it's going to be, you can see the notches and you can kind of image the triangle yourself. It's going to be like that big. It might be too big, honestly. I have to take it down another 1/2 inch. But that's how it's going to work. And each section will have its own transistor, its own battery. Tons of great stuff. All right. Now let's go into the other room. Be right back. All right. So what we have here is a dual drive and input. So we got a 1 transistor for the 18 gauge strand that's in here. 1 transistor for the 20. Then we got the trigger coil for both of them. 1 trigger coil for both of them. Okay. And now the thing that's different is that I shorted out each coil, but I put a diode in between. From back to front is how it goes. So it'll come in the front, the power will come in, go through the system, and then it'll flow around like this as long as there is power to flow. And it really like cuts. We'll look at it real quick. You can hear the printer in the background. So that's going to interfere with our ability to hear this. But that's okay because there's not much noise coming from it anyway. And this gradually increases in speed. I haven't like run it to potential yet. I don't even think I'm gonna try. And this is just for 5 volts in. The amps steadily increase, and the speed steadily increases with the amps. So I mean, it's steady. It's not like a real quick increase or a real slow increase. Actually, it is kind of slow. If you gotta like if you're in a certain time limit, I don't know if you should be doing it this way. I'm doing this experiment. I mean, if like I'm saying, like if time is an issue, I mean, you can see it's whipping. You can't hear it though, can you? That's because the coils are shorted. Um, well, I mean, it's not like they're connected directly to each other. There is a diode in between the end and the beginning. But as you can see, it's still working. And then you can see the amps are creeping up. There's our first input, and here's our second input. Pretty equal and steady. Or in wave formation even, because this one's steadily climbing. It's higher. This one's higher. And this one's just getting to 200 milliamps. This one's almost about to hit 300 milliamps. I'm thinking I should try and like hook something up to this and see if I can't get some energy off of it, because it's going pretty fast. I'm sure that field's reaching out. Now I got this coil on the other side, and it's all hooked up into itself in a great series circuit through each wire and then back into itself. I don't think it does anything, but I mean, we could always try and test that and see what happens. Yeah, it's just gonna slowly increase in speed and cost. That's so cool. See what happens if I take off the connection now, the Schottky diode I have in between each one. Maybe just put a straight up rectifier in between them. That's this one. This is 1,000 volt, 3 amps rectifier diode. Alright, we've crested 300 milliamps. So that's 1.5 watts, just so you're clear. 1.5 watts. 1.5 on the one down here too. So cool. Alright, I'm going to cut it off. And I believe you do have to run them both at the same time. You can't run them one or the other because of how it's hooked up. If I had some toggle switches in there somewhere, it would probably be able to work, but I don't. So when one cuts off, the other one cuts off too. Doesn't matter if it's still on or not. The drawbacks. And this is not an SSG. This is like a 1, 2, 3 And that's 1 for the base, 2 for the collector, and 3 for the emitter. Have 2 of those hooked up. Alright. Thank you very much. Peace out. Have a good night. Please subscribe. Bye now.